Dear student, welcome to my channel. This is the 11th video on C programming, and in this video I am going to continue with extra exercises for loop, that is while and for. Now let us start. Write a program to input a number and form the reverse of it. For example, if number is 453, then output is the 354, that is a reverse number. Now here we are using the same logic that we have already used in our previous video, that is quotient remainder. Now only we require to remember this formula. Reverse is equal to reverse into 10 plus r, and reverse is initialized to 0. This is 453, 45, 3, reverse into 10 plus r. Now initially reverse is 0, 0 into 10 plus 3 is 3, then number is decremented, that is n equal to q, 45, 4, 5. Now reverse is 3, 3 into 10 plus 5, 35. Now again quotient becomes our number 4, 4 by 10, 0, remainder again 4, then 350 plus 4 is 354, so it makes the reverse of the number. This logic already we have used in our previous video, that's why I am not wasting my time again and again explaining the same thing. Now the loop is while n is not equal to 0, we are finding quotient, remainder, updating reverse, and assigning n equal to q. Even there is no need to write down these two separate statements. We can directly write n equal to n by 10. That is also okay, but this statement should be here. Now same program we can write down in for loop. Only change is for here we initialize the variable reverse equal to 0. Final condition n is not equal to 0 and n equal to n by 10. So here only remainder and reverse updation. So program is same. Next we have to check whether the number is given palindrome or not. The number is palindrome when the number and its reverse is same. So for example 121, if we write in a reverse way, the number becomes 121, so it is a palindrome. If number is 56, it is not palindrome because 56 reverse is 65, so they are not same. So we require to use the previous program logic, that number and its reverse number, and we have to compare whether they are equal or not. If not equal, they are not palindrome. Only the thing is required that when we can compare with original number, but in this loop our number reaches to 0, so we have to store this variable into another variable. So number accepted and number is stored in the temp variable also. During this iteration, that is same quotient, remainder and updation of reverse and the decrement of number, our n decreases, and when our n reaches to 0, we will come out of the loop. So when we want to compare the reverse number and the original number, at that time we are taking the temp and we are comparing temp is equal to reverse. If it is, then it is palindrome, otherwise it is not palindrome. Same program we can write down with the for loop also. So only change is for reverse is equal to 0, temp equal to n, n is not equal to 0, n equal to n by 10. So this is the final condition, this is the iterations, and this is nothing but the initialization condition. Now we have to write down the program in which we require to make the addition of the first digit and last digit. So this program will work only more than 2 digit, but here we are not taking that much restriction, we are keeping simple. So for that our number should be greater than 10, greater than 9. Now here we are writing the same loop, but when the first time we see initially one variable count equal to 0. So when count equal to 0, it will increment as we iterate the each digit. So initially it is count 0. So if count equal to 0, what we will do, that is for example this number is 453. So first time the remainder will separate out the 3 digit. So if at that time count is equal to 0, so count equal to 0, we are giving in f digit is equal to r, that is 3 is stored in a f digit. After that we decrement and we are incrementing the counter also. Next time count increment, so this will execute only when count equal to 0, and this is only for the rightmost digit. When we come out of the loop, at that time n becomes 0 and here r becomes the 4, because at last initially in r 3 is there, then 5 is there, and then 4 is there, but after that we come out of the loops, but the value remain r is 4, it is not changed. So when we come out of the loop, we are writing L digit equal to R and just making the addition of the first digit and the last digit. Now same program we are writing in a for loop. So here we initialize count equal to 0, final condition decrement, remainder if count equal to 0, f digit equal to r, count plus plus. So it will only take only for the first time, after that it will not take that as a digit. And when we come out of the loop, at that time in the r, the last digit, that is nothing but our first digit, is stored and it is taken in the variable L digit. Now this program is important to understand. Now whether we have to check whether the program is given number is magic or not. So for example, number is 298. So what we require to do, 2 plus 9 plus 8, 19. As 19 is greater than 9, so that we can make the again sum. So 19 is 1 plus 9, 10. Again it is greater than 9, we will make 1 plus 0, 1. So when the sum is 1, at that time number is magic. So when number is 0, sum is 0, or between 2 to 9, the number is not magic. Now take the number 98. 9 plus 8, 17. 17 again split into 1 plus 7, 8. So 8 is not magic. So here we are not using the statement go to. Without go to, we require to write down the program. So once we come out of the loop, it is very difficult to again enter into the loop. So what we are doing, when we about to exit from the loop, we are checking the condition, and if our sum is greater than 9, at that time we require to again go into the loop. So we will change the condition. Now only this is the important part of the program. Rest of the program is very simple. Now see, first to 98, it will separate quotient 29, remainder 8, sum initially 0, sum makes 8. Now number becomes 29. 29, quotient is 2, remainder is 9, 8 plus 9, 17, n equal to 2. Now this 2, quotient becomes 0, remainder is 2, sum is 19, and at that time for decrement we are making n equal to 0. Now when n equal to 0 happens, at that time in the next iteration we are not going to continue this loop. So what we will do, we will check when we are making n equal to 0. So before ending the loop, or before checking the condition next, what we are doing, we are writing some if condition. Now see, sum equal to 0, n is not equal to 0, n equal to n by 10, remainder, then we add the sum, see, remainder, we add the sum. At last we are checking, that is, this is a for loop, even while loop. Before, after making n equal to n by 10, we will check if n by 10 equal to 0 and sum is greater than 9. Now what we will do, see, in the for loop and while loop there is difference. In for loop, when it will go here, then only decrement takes place, and in while loop you are explicitly doing the decrement. Now see, here what we are doing, when we are calculating the remainder 2, at that time sum is 19. For example, sum is 19. So in advance what we are doing, that our number at that time is 2. See, number is 2, 2 by 10, 0, remainder. What we are doing, sum is equal to 19. So we are taking 2 by 10 is equal to 0 or not. Yes, 2 by 10 is what? 0. So at that time what we are doing, sum is greater than 9. Sum is greater than 9. Yes, 9. So we can split. So what we are doing, n equal to sum and sum equal to 0. Now here sum equal to 0, why? Because we are assigning whatever that number greater than 9 is assigned to the number. So number becomes 19. Number becomes 19 and sum becomes 0. Again we will move out of the again we will continue the loop, and we will not move out of the loop because our n is not still 0. So n is not equal to 19. I will explain once again. See, initially first we separate out the 8, then addition takes place. At that time we will check. Now at that time number is 298. 298 by 10 is not equal to 0. So at that time, and sum is also not greater than 9. So we will not go inside the loop. Now next 29 number. So sum becomes 17. Sum is greater than 9, but at that time 29 by 10 is not equal to 0. So we will not go out in the loop. Third time what will happen, that sum is greater than 9, but at that time our number is 2. So 2 by 10 is equal to 0. So at that time it will go into this condition. Our n becomes 19 and sum becomes 0. So even your difficulty in understanding the for loop, the while loop is very easy. You can easily track. and again we will continue the condition, and if this condition again satisfied, for example 1 plus 10 for 19 it will again satisfied, so again it will see here, again it will go into the loop again. I will explain with the while loop, because if you are doing the programming initially it is very difficult for you to understand. Now see, while n is not equal to 0, we will find out quotient, we will find out remainder, we will make sum n equal to q. So when n becomes 0, it means we are not going again into this loop. So when we are making n equal to 0, at that time immediately we check. When we make n equal to 0, means we are not going in the loop next time, but at the same time we check if it is 0 and sum is greater than 9, then we make n equal to sum. So sum becomes 19, says 19 here, n becomes 19 here, and sum becomes 0. So this condition is what, while n is not equal to 0. But now you change n to 19, n to 19 and sum equal to 0. Again it will separate out 9, then again it will separate out 1. So again it will become 0. Again our sum is greater than 9. It will again make n equal to sum. So n becomes 10 and sum becomes 0. So you just try to understand this loop. So with the while loop is very easy, but only for loop this will come only after this completion, this will comes into the picture. So that's why we are checking in advance, that is if n by 10 equal to 0 and sum is greater than 9. So that is a subtle difference between the for and while loop. So if you do practice, then you can easily understand this, but if you are at the initial level you can do with the while loop, because for this program while loop is somewhat easy to understand. And after that, when you come out of the loop, our sum is always between 0 to 9. So when sum is 1, it will print magic, otherwise it will print not magic. So we print sum here, and if sum is equal to 1, it will print magic and it will not print magic. So this is very important, that when n becomes 0, we will come out of the loop. So when n equal to 0, at that time again we check immediately condition, and from that condition we will take whether to iterate the loop or not again. Now this program is very easy. Neon number. So what is a neon number? Number is 9, its square is 81. Sum of the digits is 8 plus 1 9, which is equal to our original number. So that number is what? Neon number. See, this is number, we make the square. Now we require to find out the sum of the digits of square. So while Sn is not equal to 0, R, same logic. After that, whatever sum we are getting, that is nothing but 9, and 9 should be equal to our original number. So here there is no change in original number, because we are calculated the sum of the digits of square number. So square number becomes 0, but our original number remains unchanged. So we can directly compare sum equal to and neon, else it is not neon number. That's why whenever you write the program, every statement you can't remember. You require to understand what variable names you are using, what is the state they are reaching, and how you want to compare the condition. So everything you require to check. The same program you can do with the for loop. Sum equal to 0, Sn not equal to 0, Sn equal to Sn by 10, and in this way you can do. This is somewhat difficult to understand again. Automorphic number. What is meant by automorphic number? Is a number whose square ends with the same number itself. For example, number is 5, square is 25. Now this number ends in a 5 and our number is also one digit. This is match. Now take 25. 25 square is 25. So number is 25 to 5. So what we require to, what is the logic? So before the logic, we will have to know that whether our number is one digit number, whether our number is two digit number, whether our number is three digit number. So means basically we require to count how many digits are present in our number. So see, we will take 25, we count the number of digits. So number of digits are 2. Now we take the square of that number, 625. Now we have to extract last 2 digits from that numbers, from that square number. So when we use divide by 10, last gets separated. When we divide 100, last 2 bits. For example, if last 3 digits are 3, then we require to divide by 1000. So based on that, we require to do the operation. So n equal to 5, number of digits equal to 1. Sn is equal to 25. I have taken the example of this. Our number is 5, number of digits equal to 1. square is 5, so we have to extract how many digits? Only last one digit. So for that we are using mod 10. If we want to extract 2 digit, 100. If we want to extract the 3 digit, 1000. So in this way we require to do. But as we know, we don't know that whether to use 10, 100, we have to make generalized formula. So how we can make that formula generalized? Sn percentage, that is nothing but the separate digit from the square, power of 10 comma number of digits. So this is nothing but the power function, base raised to exponent. So 10 and number of digits. If number of digits are 1, then 10 raised to 1 is 10. If number of digits are 2, then we require to take mod of 100. So 10 raised to 2 is 100. If number of digits are 3, 10 raised to 3000. So this makes the generalized formula. So this, in this way you have to develop your logic. So when you take 3 to 4 example, you will come to know that. So what we come to know that we have to find out how many digits are there. Then based on digits we require to divide by that particular value, either 10, 100, 1000. So how we can make the generalized? Sn is equal to percentage power 10 comma number of digits. Now the program is very easy to understand, because almost in all programs we are use similar logic. Remainder separate digits n equal to n by 10. So this is only to count the number of digits. So after this loop we are getting the total number of digits. Now we use power is equal to power 10 by digits, because we have to use this function as a denominator. See, if temp is equal to Sn mod power, Sn is nothing but square number divided by that particular number. For example, 620 mod of 100. If it is equal to our original number, so here again we can see that when we are finding the total number of digits from a number, our number again becomes 0. That's why there is need to store that number in one other variable. So here initially temp equal to n changes to 0. After that we are comparing this Sn power. So this is nothing but what? This temp is nothing but 25, and this is nothing but Sn is nothing but 625. But we are taking the 625 mod of 100. Mod of 100. Why mod of 100? Because 25 number is there. So 25, that is total number of digits are 2. So that is nothing but what? Power of 10 comma digits. Digits are 2. 10 raised to 2 is what? 100. So that's why here 100 number comes here. The program is very simple. Only you require to understand this type of logic. So this logic and counting the digits, two things are required to complete this program. And once we do the program in while loop, it is very easy to do in a for loop. See, digits equal to 0. We are storing the temp n variable in temp. This statement is important and this statement is important. Now I will not explain this program. It's very easy. Now we have to check whether given number is pi number or not. Pi number when sum of the digits is equal to product of its digits. So we have already did a lot of programming like this. So for example 1124, if we add 8 and if you multiply, again we are getting 8. So this is pi number. 123, 1 plus 2 plus 3 6, and 1 into 2 into 3 6. This is again pi number. So we require to take sum of the digits. When we do sum of the digits, at that time some variable initialized to 0. When we take the product of the digits, that variable initialized to 1. And after the loop we have to check. So this is the program. While n is not equal to 0, we have calculate sum of the digits. So sum of the digits initialized to 0, product of the digits which is initialized to 1. And same program I have written in the for loop also. If sum d is equal to prod d, they are pi number, otherwise non-pi number. This is again very important to understand that how we end the loop. Now we have to check whether given number is pronic number or not. So what is a pronic number? Which is the product of two consecutive integer. For example, 12 is a pronic number because 3 into 4 is 12. 20 is a pronic number because 4 into 5 is equal to 20. 42 is pronic number, 6 into 7. Even 56 is pronic number. So what we require to do, for example, if none input is 12, then we will try with 1 2. If 1 2 not okay, we will try with 2 3. If 2 3, we will try with 3 4. If 3 4, 3 4s are 12 and it is matching, so that number is what? Chronic. Now take the example of 14. So we will start with first 1 2 not okay, 2 3 no, 3 4 12, it is 14 no. Next number is what? 5 into 4. Now 4 into 5 is 20 and our number to check is 12. So our condition is not valid because whatever this multiplication is greater than this number, so we can't check. So what we require to do that this multiplication should be less than or equal to given number. That is very important condition. C, I into I plus 1, because we are checking 1 2 2 3 3 4, that multiplication should be less than or equal to 1, then only checking can be possible. So for 14 we can check with 1 2 2 3 3 4, but match is not there. But we can't check with 4 5 because 4 5 multiplication is 20, which is greater than 14 number. So see, this is the simplest logic. Now I will explain the concept of flag also. Now see, we are accepting the number while I into I plus 1 is less than or equal to 1. So this is our end loop. If it is equal, then what we have to do, we don't want to do continue operation, so we are using what? Break. Break is always break from the loop and not from the if. This is very important. So if nested loops are there, it will break. If we are written the break inside the nested loop, then it will break from this loop and it will goes to the outer. But when only one loop is there and when we have write break statement anywhere, it will just break out the loop. It will never break from the if else. So when we write, see, this is a condition, if it is match, then our chronic number is match. Chronic number is match. So what we will do, we will make flag equal to 1 and break. So when break happens, break will happens from the loop. And if not, we will check with the next I value. For example, see, number is 12. We'll check with the 1 2. 1 into 2 is equal to n, no. It will increment I plus plus. Next we will check with 2 3 not match. Next we will check 3 4. When 3 4 is matched with this condition, it will make flag equal to 1 break, and break matlab out of the loop. So when we break, then at that time out of the loop, at that time we don't know when we come out of the loop whether our loop ends or our loop breaks. So what we will do, we will write down the flag. So when we will break, when our condition match, at that time our flag becomes 1, otherwise our flag becomes what? Our flag is remain 0. So whenever we match this condition, then only our flag is going to 1, otherwise our flag remains to be 0. So when we come out of the loop, we will check whether flag equal to 1, then we break. When match condition match, therefore it is a chronic number, otherwise it is a not chronic number. So in this way we have to check. So why flag is important? Because here we will come at this place, that is out of the loop, by two way. One way is that when the loop ends, and second when our condition match. But there is no way to tell when we come out here how we come out of the loop, either by breaking the loop or by end of the loop. So when end of the loop we come, flag remains 0. When we come through by breaking the loop, flag becomes 1. So this is nothing but the test condition. Now in the next prime program also we will see the condition in detail. Same program for the for loop. For I equal to 1, flag equal to 0, initialization takes place. This is the final condition, this is the increment. This is a prime number program. So prime number is a number who divides by other than 1 and the number itself. For example 7, when we divide by 2, 3, 4, 5, 6, it is not divided, so remainder becomes what? 0. Remainder is not 0. 35, it is not divided by 2, 4, 2, 3, 4, but when it is divided by 5, the number is not prime. This number is divided by 5, so number is not prime. This number is prime because other than 1 and 7, this number is not divided by anything. Now this is again very simple program. Now when number is 1, it is not a prime number. So this condition we are writing explicitly. If our number is 1, this is not prime number, return 0, because we have to return, otherwise we will go, if we don't write return here, what will happen, it will go here also, that will be possible. So what we are writing, that not here, it will not go directly here, but it will print this value. So that's why we don't want, that's why return 0 is 0. When our values are more than 2, at that time it will check for I equal to 2, I is less than n. Now I is less than n, that also we can check, but when numbers are very large, at that time this condition is also okay, that even if we check half of the number, then also it will work. So that is the efficient condition. So either you can write down I less than n, or I is less than or equal to n by 2 I plus plus. In between, if that number is divided by I, means it is not prime number because it is divided by something. So we make flag equal to 1, and by default flag is what, 0. So when number is divided by something, then at that time flag become 1 and you break from the loop. And sometimes when you are not going into this condition, still also you come out of the loop, at that time your flag is 0, means that number is not divided. That's why when your flag is 0, the number is prime, else number is not prime because it is divided by that I value. So here this condition is flexible, but for large number this is the efficient condition. Now the same program I have written with the while loop also. Now you've understood that either we can write down for and while, only we require to check the condition. Only for the program like magic number, it is better to use the while loop in the start. Now next program is very easy, to check whether composite number or not. So the numbers which are prime, they are non-composite number, and the numbers which are not prime, they are the composite numbers. That is, they should having more than 2 factors. So a composite number has more than 2 factors, and all non-prime numbers generated greater than are composite. So only we require to write down the exactly opposite condition, that flag equal to 0. Here actually when prime number is there, it is nothing but non-composite number. When they are non-prime, it is composite numbers, and we generally skip this condition because this is not required for the composite number, because composite number we generally check from the 2. So we can skip this condition. So this is about for and while program and developing the logic. So in the next video also I am going to check, I am going to take some more problems on the for and while, so that even any problem comes, you are able to solve that problem by developing the logic skill. Thank you.